gentlemen. It's my pleasure to welcome you to the last round of our lecture series on sustainability in computer science. As I already said, we started with sustainable security, a presentation from Daniel Cruz from TU Graz. We have as our last presenter my esteemed colleague, Professor Franz Wotawa from TU Graz on sustainability in software engineering. So far, the journey has been a very, very interesting and exciting one, and I'm pretty sure we will be more excited even over the last couple of minutes and hour by Professor Wotawa. We have heard a lot about kind of energy savings at the hardware level over the last presentations, and I guess it will be even more interesting today when we hear about what we can do with software engineering and with algorithms. So Franz, it's your floor, and it's a pleasure to have you here.
Yes, Gerti, thank you very much for the kind introduction. It's good and bad to be the last one in a row, and especially when you haven't looked at the previous presentations. Anyhow, I will try to give you a valuable information about sustainability in software engineering. And as already said, let's say it. I was when I prepared the slides, I was thinking about what others have already formulated, and therefore I avoided going again through all these figures showing that computer science applications have a huge impact on the CO2 emissions and other things in here. You should have heard that a lot, so I'm avoiding that. Software is important, okay? There are some papers dealing with software eating the world. Software is important not only for, let's say, us as computer scientists, but basically all devices you have now here are based on software, hopefully on quality software, on software that fulfills some certain quality criteria in here. And to give you some numbers here, it's not a precise number because it's always changing. But for example, when you have a look at the automotive industry, 20 years ago, there was only maybe 1% or 2% really software-related costs. At the moment, I don't know exactly the costs here, the figures here, because it's a little bit difficult really to capture. In many cases, we see electronics, and under this terminology electronics, there is also then of course the software that is running basically these devices, the sensors and so on, is also in here. So my estimate is at the moment that we are about 30 to 40%. Anyhow, there is also the terminology coming up, software-defined vehicles. So in the future, like we saw in mobile phones and so on, all the functionality is basically utilized using software. And of course, and I hope all of you agree, when everything is running on software and software is really implementing functionality, then of course the software influences also the energy consumption, which has of course a direct connection then to emissions basically. And that's something we have to agree on more or less, or see basically. Why, to give you some example, why can software have an influence? For example, there might be a fault, for example, in a control algorithm used in automotive, and then the car is requiring more fuel, for example, than expected. So this is one thing. And even in the case you have an electrified vehicle, at at least these days, and maybe in the next 10 to 20 years, there will be a portion of electrical energy that is basically coming from, yeah, it's we require there, let's say, at least some sort of either gas or other things that lead to CO2 emissions. So anyhow, here we would also see when there is a fault and consumptions are higher, then of course this has an impact. Of course, what we also have to consider, for example, is that development itself has an influence, because when we are developing software, then we are more or less using computers. We are using computers for various purposes. They require energy and so on. So this is also one thing that leads to higher emissions when we are not doing that in a very consequent, in a very energy saving mode. And of course, when the software is running and not having a fault, but is programmed badly, having more iterations than we also see necessary, then we also see here problems coming. So this was more or less the introduction statement, and I will go into detail what you can expect from me for the next more or less 40 minutes. What are the objectives behind? First of all, what I want to give you is an answer about why does sustainability matters for programs, and of course then also for software engineering. What do we understand about software in sustainable software engineering? Of course, there are many things we can define it, and I will come with some of these definitions. You can find also in available literature on that. And finally, and this is for me the most interesting part, is how can we support sustainability in case of software engineering? And here I will give you an example of using genetic programming for coming up with a program that basically has less energy demand. Finally, and I will explain how this is working. And this is one application where automated tools that change source code may lead to a more sustainable software, when we understand basically a software that has the least energy consumption values possible. Okay, let's start with the first objective, sustainability in software. So first of all, as I already said, is that software is becoming increasingly important, and there are parts, or there are articles showing that this here is in the automotive industry, for example, quite recent ones. When you go back, then there are a lot of other articles available showing that software is of increasing importance. And when you have a look that maybe ICT is about so relevant for about 2 to 4% of greenhouse gas emissions at the moment, there are deviations of these figures in here. It's not, I would say, not exact science here, unfortunately. Anyhow, in all of these ICT things, there is software running. And if the software, as I said before, is not working as expected, that might lead then to more emissions than required. So ideally, we should keep energy consumption values as one of the quality attributes in here in order to avoid here bad programs, more or less leading to a lot of greenhouse gas emissions. And what I also said here is that developing software itself consumes energy, depending, of course, on what you're doing. But you can imagine that when you run a compiler every minute, that is more costly than running the compiler maybe only once a day. And if we make our processes in a way that the use of tools, the use of other software for developing software is reduced, then of course the energy footprint can be lower. Whether this is good or not is a different story, because in software engineering, of course, there are many other tools, and sometimes we want to have tools that immediately tell us when we are doing something wrong, when we introduce bugs in there, and not only during nightly builds, so once a day. So we have here some competing things we want to optimize, and here there must be some maybe some new processes that consider, as I said before, energy consumption here also as a quality attribute, and then the things would be more better. When we talk about sustainability and sustainable development, there is this Brundtland report from the United Nations defining that as the ability to meet the needs of the present without compromising the ability of future generations to satisfy their own needs. So it's basically something to say, okay, we should leave the world in a good shape, and if we are doing things, then it should not be negatively impact the future in here. And in order to do so, of course, we need to consider more or less requirements on three dimensions we have here. It's the society, economy, and the environment. In many cases, we are focusing mainly on the environment, but economy and society, and we see it with a lot of debates here, that of course they are closely related, and changing only one part may lead to unexpected other things that may negatively impact the whole consumption in here. So we have to be also somehow careful what we are doing. Anyhow, I think with this United Nations report, or the definition, that's I think a valuable piece of work in here. It's not only the United Nations that deal with sustainable software engineering. When we come more or less to the second part, which means what is sustainable software engineering, what is sustainability in software engineering in general. For example, when you make a Google search, then you find immediately Microsoft pages on that topic. So it seems to be quite important also from the perspective of getting money from that. And Microsoft defines sustainable software engineering as an emerging discipline at the intersection of climate science, software, hardware, electricity markets, and data center design. And the principle, of course, of sustainable software engineering are a core set of competencies needed to define, build, and run sustainable software applications. This is a very general definition, I would say. Anyhow, it's saying that's emerging from other parts in here. It was not in the primary focus of software engineering before. Anyhow, it is important, undoubtedly, and it needs to require or it needs to consider different aspects in here. Then there are also articles on that, like a Forbes article from now I cannot say last year, but 1.5 years more or less ago, defining sustainable software engineering or sustainable software development as something that is becoming more and more popular these days. And it's basically an approach aiming to design software that will increase overall application efficiency and reduce energy and space consumption requirements. So it's a very, I would say, optimistic thing here. I'm not sure whether all software developers really are now taking care about environmental aspects, but what I see is, of course, that it's becoming more and more of interest. And as I said, the only way of introducing that is, of course, besides changing a lot of processes, but also making that a quality attribute we have to consider in software engineering to get that running. There are many definitions, and this is maybe something I also want to say. If you have a look at the literature, there are many definitions. Most recently, maybe some of them converge. but still, of course, it's not an area that is completely 100% defined, I would say. There are some aspects I think we agree on, and this aspect is basically that we want to have software where both development and deployment, which means, of course, also the use, results in minimal direct and indirect negative impacts on the economy, society, human beings, and the environment. So we have here that what we saw in the Brundtland report, those facets here are also captured. And ideally, of course, there should be a positive impact in here. What are now indirect negative or direct negative and indirect impacts? Of course, direct is when the software is running, let's say, more often than required. Then, of course, it's more or less a direct impact, because this has then to do with the energy consumption. Indirect is, of course, when you run a compiler more or less. Then of course their energy is needed, and so it impacts, of course, also the energy use and therefore the greenhouse gas emissions. Anyhow, what's also mentioned that there is a prerequisite for sustainable software, and this is, of course, the development process, which should be also sustainable, which means considering also the environment in here and the impact, and I will come to that point a little bit later in my talk as well. And when we are considering the software and the development process together, then we define more or less sustainable software engineering as the art of developing sustainable software through a sustainable software engineering process. So this is more or less the direct result of this discussion in here. And as I said, it's more or less an emerging discipline. It's on the intersection, as I already mentioned here, on different disciplines. And there is a lot of things to do, which is good for scientists, because we can think about that and come up with interesting solutions, and also with interesting PhD thesis topics. And I think this is something, of course, we always are interested in. When we come to the dimensions of software sustainability, we have here, of course, the human sustainability, which means how software development and maintenance affect the sociological and psychological aspects of software development community, and of course the individuals here. This is one aspect of sustainable software. The other one is about the environmental sustainability, green software, which is usually the focus in here, I have to say. So usually we are focused on this part here. That's how the software lifecycle processes protect stakeholders. How software product development, maintenance, use affect energy consumption, more or less. And the last one is the economic resources, which are, of course, dealing with lifecycle processes to protect stakeholders, investments, benefits, and so on. So this one here, the economic sustainability, deals more with software that is not so bad that everything I'm going to invest will be lost immediately. So human sustainability and economic sustainability are things that may be considered so far, because also in the life cycle or in the processes, because their developers, we have to deal with resources, with budgets, and all these things, and also other quality criteria that come into that game about economic sustainability. And for the humans, of course, there's always, let's say, the debate which are the best processes in here for developing software. And the last, I would say, 20 years, there was a tendency to going to the agile processes. And that was mainly driven by the developers, I have to say, not only by the companies. And it seems that developers like these processes a lot. So you see, at least, that in most of the cases, the let's say human sustainability and economic sustainability are or have been already captured to some extent, but the middle part is environmental sustainability, which is also called depending on where this sustainability comes from. Green software is, of course, something we are still interested in. And here we come to more or less the main part, and also where I'm more or less more interested in, and that's green software engineering, including practices, green practices in software development. And let's go to these figures here on the figure here on the right. There we can distinguish, when we have green software, two parts. One is green by software, that's the rightest part here. And green by software means basically that we are coming up with software that supports, let's say, CO2 reductions or other greenhouse gas emission reductions, optimized processes, software that supports optimized processes, and so on, or also modeling software and all these things we can have in here. But for me, the most important thing is more or less this green in software, which means basically how to develop software that has a minimum impact on energy consumption, and of course also minimum impact of energy consumption also during development as well. And this is something that is here more or less in the focus of most of the papers that deal with green software. Green by software is here maybe, I wouldn't say minor, but they're not, or it's not in the main focus, I would say, for when we talk about green software, but maybe that's my personal opinion on that. To clarify, maybe before I forget it, what software engineering means, this is also quite interesting thing here, is it means the application of a systematic, disciplined, quantifiable approach to the development, operation, and maintenance of software. That is basically the application of engineering to software. And why I'm mentioning this here, first of all, when we are talking about engineering, then we always talk about optimization. So we want to develop things, but not in a way everyone can do that, in a way that is optimized. So with least cost, with best benefits, basically with the best outcome for costs and so on. And when someone comes to your place, then and you're an engineer, then you are devoted to that. You want to have here more or less the best product under certain requirements, of course. And software engineering, when the term was more or less introduced more than 50 years ago, this was more or less a contradiction, because software development was more or less an art and not an engineering discipline. And there were a lot of problems with this approach. And one of these problems was that there was no quality assurance. There was no real process that helped us here to come up with, let's say, with an optimal way that always leads to a good software, considering the given requirements and so on. So this was something that basically was not that ideal. And so people in a NATO conference, they were sitting together and thinking about how to overcome these problems, because it was also, let's say, corresponding to a lot of loss of money and other things. And then people were really thinking about how these engineering processes and how this engineering can be introduced in software. But still, of course, software engineers are all, to some extent, still artists, I would say. But anyhow, the processes are becoming more strict. And with having these two things together, the final outcome is also better. And now the question is, of course, how to do that in order to come up with green software. Okay, to give you here the relationship to that. So to summarize the discussion, in a close sense, of course, software sustainability captures only green in software. And as I said, this is the important part, at least for me, focusing on the development and maintenance of software, contributing to the reduction of greenhouse gas emissions in here. And here we can see two ways of doing that: reduction during development, reduce compilations, for example, or minimize learning in case of machine learning based software. I'm sure you heard that learning one of these models, these large language models used by ChatGPT, costs a lot and also a lot of energy. So when we come up with such a software and we learn continuously, then maybe we are using a lot of energy, and so we should always think about that, and so on. So reduction during development, there are many possibilities for doing that. And then, of course, there is this reduction during use, where we should develop programs that minimize the footprint of greenhouse gases. And this is maybe the even more important part, because development is done once. Of course, there are some maintenance work here and other stuff. But when you consider, for example, Microsoft and other big vendors, there are millions of instances running every second on the world. And if you're saving here small parts of the energy, then of course you can save huge part in total. And this is the message here, that of course it might be more important to focus on the development here, to come up with good programs that reduce the greenhouse gas emissions. When coming up with the slides, I also always thought that it would also be interesting, of course, to have a look at how much research is carried out. And I have to say, this is not so much here. So there are two papers I considered here. The last two I found about systematic literature reviews or mapping studies. They're not in the same time scale, and you see, and also the figures are somehow different. All of them claim to deal with green and sustainable software engineering here and sustainability in software engineering. The numbers are a little bit different, as I said. In many cases, the last numbers here and yeah, maybe here is better, or maybe not that relevant. Anyhow, when you see it here, you see that the numbers are different. Anyhow, what you see here is that there is an interest, but it's not so much at the moment. Okay, and when you have a look at the latest also papers in conferences, there is not so much, unfortunately, in software engineering, and it is green software engineering. Maybe they changed the last years, but when you have a look at that, when the term sustainability, green software was more or less introduced, there are only a few publications, maximum was mentioned here, 29, that were at least mentioning some sustainability aspect of software and programs. And so what we see here is that there is room for improvement. And I will come later on to one of the solutions. And in this, you see also that there are a lot of open questions that still remain in here, making it an attractive research area. When we deal, and this is maybe the aspects I want to raise now. What we said here is, to come back to that, green software. So there is this aspect of developing and the impact of development. And on the other hand, there is, of course, the product here. Of course, it's also influenced by the development, but maybe by different parts. And the question is here, how can we come up with process and quality models for sustainable software engineering? Here is a paper you may want to look at. And basically, what are the conditions we want to have? So first of all, of course, we want to meet sustainability objectives, whatever they are. So we are coming later on to that. We want to have a minimized negative impact to the environment, but also to social things in here during its use. Okay, so this is the important part in here. And of course, the software functionality should, in the development, should also not have a negative impact. So this is what we already discussed, summarized here for clarifying what a sustainable software product would be. There is a model that is mentioned in this paper. Due to time, I will not go through all the details here. Basically, what they consider are these 4 parts. One is the life cycle of a software product, where we have development, usage, and end of life, with first, second order, and third order effects on sustainability. Effects on sustainability require, of course, that we need some criteria, some objectives we want to meet, and metrics. Of course, we can always say it's the energy consumption, but anyhow. Criteria and metrics are important because they are often used for software engineering to guide the process and also to finally make an assessment for the quality. And so we see here also that this is something of importance. Then, of course, the procedure matters in development, administration, and use, of course. And there is a huge, let's say, area where we might be interested in tools that support the whole process. And these tools can be either recommender systems that help us to find out those parts of the program which are not that energy efficient, and give us recommendations on that topic, or tools that assure maybe energy efficiency automatically, and so on. So there are many things we might want to have, or maybe tools that restrict energy consumption during operation, whatever, if this is possible in here. So all these 4 parts, of course, need to be considered when coming up with sustainable software. And let's come up with, some quality model. As I said, quality is important, and quality needs to be defined. And quality, of course, we are interested in has to do with efficiency, reusability, modifiability, usability, and all these things here. Okay. Of course, also correctness, maybe robustness, whatever. So when you are dealing with development, and also in particular software engineering, then of course you are interested in a lot of quality criteria. There are common criteria. These are the ones that are mentioned in here, that can be summarized more or less under efficiency, which are runtime, efficiency, memory usage. I'm only mentioning some of them here, or CPU intensity, and so on. There are quality criteria about portability, which may has to do with adaptability. So can you reuse software on different machines, different operating systems? What's about this hardware obsolescence? So where you know that hardware stops working too early, and all these things, and so on. We may consider that, or for feasibility, we may have a look about carbon footprint, energy consumption, waste, and all these things that may occur during a process, and to come up with criteria in here. This is always the important part. People oversee in software engineering that everything. So when I ask students what is good software, then the first thing what people should come up is with a definition what means good, and this is a definition of the quality criteria basically, and all of them should be. We should be able to test them basically. So we need to verify and validate all these quality criteria, and otherwise they would not be very meaningful. And so for software engineering, because it's driven by these quality criteria, it is essential to define these things, and also the measurement for obtaining it. So anything that, so if give you an example, what can never be proven is the software has no faults in there. Okay. So you would need, and if the software is complex enough, you would need a lot of things to really justify that the software is correct. You can easily prove, or not easily, but you can prove whether the software is not doing well, but proving that it's doing correct is not really possible for complex software, and therefore such a criteria does not make sense. And here in this term, we should come up with concrete quality criteria. So energy consumption is one of these that can be measured. Then, of course, the first part before maybe the development is also the process. We have to have there are several different processes that may deal with sustainability. One is this process-centric software sustainability, where we have a sustainability management process. So sustainability will be then a criteria we have to consider in here. We have, of course, here also the sustainability directly in the engineering process and in the qualification process finally. And all these things here are more or less to be defined. So what you see here, and I will make the slides available so you can read that, is more or less some indication what is meant under this. But for a concrete development process, we need to specify that. In a second way, of course, we can also think about an agile software engineering process that is sustainable. In this paper I mentioned, they were doing this by introducing two main activities. One is the process assessment, where there is a focus on sustainability of the software development in here. So there will be a continuous activity during the development process, collecting and data about carbon footprint of the development and all these things in here. And there will be also then sustainability reviews and previews where we are focusing on whether we have achieved what we wanted to do with these sustainability requirements. And of course, there are then another rule in here, which is the sustainability executive, who handles also sustainability as an additional quality criteria. And this can be integrated in any agile process in here. There are more papers about this in detail. However, of course, the question is here, can we do better? Is it possible, for example, to assure that you write something that is not sustainable, but then will be sustainable? So can we automate producing sustainable software? And this is a little bit different from the processes. So we're not considering the process here. We are now considering a technology behind that would allow that. And I will cite a paper that deals with that. And the methodology behind that is so-called genetic improvement, or GI, that is doing that. Genetic improvement is more or less a term introduced by Mark Harman, who is one of the experts on software testing. He's I think he switched to Meta. He was at the Imperial College. Maybe he's partially there still. And he was always interested in also in the practical part. And this genetic improvement, the idea is using genetic programming or genetic algorithms to optimize certain quality criteria. And in this case, of course, it's energy consumption, which is then something considered as a matrix capturing sustainable software or green software in here. I'm not sure how whether you know genetic algorithms. I have here then a very short introduction into that. Maybe you heard that about when it comes to search and all these things. But before going to that, may have some ideas why tools are important. One problem with sustainable software engineering, besides, of course, introducing this as a quality criteria, is that it's not easy to produce energy efficient software. So because there is usually, a programmer writes something, but the programmer has no clue whether that what is written is really, let's say, reducing the energy consumption or not. And what is the energy consumption when I'm writing a code? So this is not aligned in here. The other thing is we usually don't have a deep understanding of how a particular compiler works. So that means we are programming, and then we are using a compiler to convert that into something that is machine readable in here. But we have no clue how this is working really, exactly, precisely for the particular program. Can we optimize that? Does this make sense to optimize? Which instructions are used in there? what is the energy consumption of these instructions, and so on. And all these things are not really available, so which means basically that there is more and more research needed, but it's also very hard to tell because a compiler optimizes in several different directions, and sometimes, let's say, the space consumption is very much important, or memory consumption, and then maybe statements are used that are more powerful and maybe requiring also more energy here on the processor side. And I'm not sure whether there is really, let's say, a one-to-one mapping between instruction and energy consumption available for all the different processors and also for the compilation. Yeah, so coming up with metrics that can be used for more energy efficient solutions would be required. And of course, it's often the case that small changes are leading to better results or worse results, depending on the change, and so on. And so when saying all this, it would be nice to have a tool of doing that, to guide users to an energy efficient software finally. And so we need a method that decreases software energy consumption, but ideally in an automated way. So how is now genetic improvement working, or genetic algorithms working in this case? So the idea here is, of course, to optimize the energy consumption. Here, what you see is the ordinary, let's say, development cycle where we have, or the verification cycle, basically, where we have test cases, and we have a program. And ideally, of course, finally, after development, all the tests should be passed and none should fail, which means all the tests should be, let's say, leading to a result I'm expecting. And here it would be interesting, when we come to sustainable software, to introduce further the energy consumption as a requirement. And then we can also say, okay, a test case produced, let the program to produce or need more energy. And so we would be able at least to clarify this in here when we can measure that. And genetic improvement now is applying changes to a program, coming up with a new program, B prime maybe, that behaves like B. So all passes are passes, all fails are fails, but the energy consumption is now limited. And this is basically something we can achieve using genetic algorithms. I think there was already a lecture or a course on search. Genetic programming is one of these possibilities to have a search function where we have a space where we want to start somewhere and then we want to be somewhere where it is, let's say, better with respect to a certain function. And the idea is basically really using genes, presenting the problem as a genetic or a set of genes, applying then crossover and mutation and selection until we optimize a certain fitness function. Here are some ideas what mutation is. Of course, mutation changes the genes slightly. Crossover is taking two genes and then combining them. And finally, the whole genetic programming algorithms works as follows. We have a population, then we are applying some functions. We are selecting those items, so those new genes, more or less, or chromosomes in here in general that are fitter. And then we get a new population, and then we restart the process until we have reached the selection criteria. So, for example, minimizing the a certain fitness function. In our case, of course, it's easy. It's a fitness function that says that more or less all test cases are fulfilled, or the same test cases than the original. But we want, in addition, have a more energy efficient program. Genetic algorithms working on these crossover, mutation, and selection, as I said, to that, and using fitness functions to select certain chromosomes in here. Because of time, I'm now going more quickly through the slides in here. The genetic algorithm starts with a more or less randomly generated initial population, selects population based on the fitness function, performs crossover and mutation with some likelihood. Then, of course, we're asking whether the results are now good with respect to the fitness function. If not, then we are again selecting populations and performing all these operations in here. So it's a iterative process that often lead to quite good results, and which is quite often used also in software testing for coming up with test cases. So there's a huge community called search-based software engineering or search-based testing that uses these genetic algorithms in here. I will go now very quickly through this rest of the slides. There is a nice paper by Bruce Betke and Harman, as I said, on reducing energy consumption using genetic improvement. It's a nice read, I would say. The idea is to convert the source code into a form where we can apply some mutation operations and, of course, crossover as well. For mutation, we are using change operations like delete a statement, replace one statement with another, or copy a statement from one line to another. The idea here is is always that everything we need for a program is already in the program, so we can copy it from there or move it somewhere. And with these move and delete operations, we finally come up with something that is more energy efficient in here. So as an example, when we have a loop statement, it's also considering the type of an expression. When we have a loop statement, the condition in particular, then of course we only allow the condition to be replaced by another condition and so on. And so this reduces somehow the search space and makes this genetic programming, genetic improvement applicable, basically. As I said, the fitness function is here the energy consumption, where they use the tool for that. And basically what they did is they proved that their implementation works very well for one program only. So this is there is room for improvement. It's Minisat. It's a SAT solver. They genetically improved in here. And I will go through these things here. It's not so much important about Minisat I already mentioned. They used the genetic improvement not only for one set of inputs, which means theories to be proven, but for three. One is a combinatorial testing model, the other one is a sample, and the other is a proof. And they separately optimized Minisat for those three logic theories, basically. The energy consumption was estimated using a tool, the Intel Power Gadget API for Mac OS, and there they got more or less the fitness functions for their tools. What's interesting are the results. So what you see here is the energy consumption reduction using genetic improvement. And the reduction was between, let's say, 4.6% more or less and 25%, depending on the application, on the basically on the theory they want to prove. And it's nice that in all cases, and champion means the best one, the best improvement after several runs, we see here in all the cases we have really an substantial decrease of energy consumption using the genetic algorithms in here, which is good at all. The bad thing is here that, of course, that one it has to be adapted for the particular application, and this is something that is not that ideal. And they also showed what would, let's say, is it possible to use one application, one optimization for other optimizations? Unfortunately, only for one case they were possible to run it. And there we see small but still improvements as well, so which range between 3 and 3.4 and almost, let's say 4% improvement in here, which is less than for the original approved version. Unfortunately, for the best, that was the ensemble optimization, it was not possible to use it. The reason is timeouts and these things in here. So it was a change that was not acceptable for all SAT solving applications. What's also interesting, and this is more or less where I will more or less finalize here my presentation of today. It's a clear indication that the runtime and the energy consumption are in a good correlation. So we see always a linear, more or less correlation between runtime and energy consumption. So this would indicate that when we are coming up with programs that have a reduced runtime, then it's most likely also leading to a reduced energy consumption, which would make our life as a software engineer easier because we only need to capture or focus on the runtime as a non-functional criteria in here for software development. So this is maybe a good thing, but still it's only one example, and so further tests are required. Yeah, so to summarize everything, we discussed defined sustainable software engineering, green software. We discussed also influencing factors of sustainability on the process side and also on the product side. And we discussed also a method for converting program into less energy or a program that requires less energy resources, which is here genetic improvement. And yeah, of course, we are not at the end here. Sustainable software engineering is not commonly agreed on, so there are many things we can think about. So there's, at least I didn't find that no general definition on that. Finding programs that are, of course, let's say, having improved energy consumption, less energy consumption, is valuable, and here there are some indications that runtime is a good estimate for that. So I think it's more or less clear, but maybe not in all respects. So there are some open challenges here as well. And what's also quite good is that AI approaches here are very valuable. That might lead to expert system decision support systems, helping developers during development for improving the software, or maybe also using LLMs or other deep learning for doing this job. So a lot of PhD theses that can be done in this direction. And this leads to the end, unfortunately longer than expected. So I'm ready.
Very good. Perfect. Thank you very much for this presentation. You know, normally, in fact, all the presentation that I ended in saying, it's really, I don't have to read some crime story. There is enough excitement in the presentations. So the floor is open for questions. I'm looking in the chat, but in fact, I start immediately. Do you teach what you research? And do you teach sustainable software engineering?
Not at the moment. So we are teaching some methods. So genetic algorithms. Also, because I'm working on software testing mainly, of course we use these methods, and we have some experience on that. When I was invited for giving, let's say, being part of these lectures, yes, I had a look at that, and I have to say they are very interesting things. So I'm now thinking about introducing that more in teaching as well as also in research.
Because you know, I'm really convinced, as you said also at the beginning, that we as a computer scientist, we have a say in this topic. And I think it's our obligation to kind of to teach the students, since we are teaching the future, to teach the students the right thing and the thing right. And I guess at a certain point they will ask us to, and I think it's totally important to say that what are you know, these different the different metrics, the different quality criteria, and so on. So
Yeah.
This would,
Definitely. So next semester I'm giving a course on software technology, and there it will go into, yes, definitely. It was also quite interesting because this work from Mark Hamann
Mhm.
that come to my attention, I think 5 or 6, 7 years ago. So it was a long time ago, and it was quite interesting because it was also judging the. He was not saying, as I said, that the program must be correct, but he said, okay, sometimes we can come up with a program that is not always correct, but having then less energy consumption, but correct enough, whatever that means
Mhm.
here.
Mhm.
And
Mhm.
he did additional work to that, what I was presenting today. But
Mhm.
it, yeah, it's an interesting topic, and bringing these non-functional requirements in here, I think it's valuable. Yeah,
There's
definitely.
a question in the chat.
Yeah.
Um,
Ah,
you can also read it. Could it be familiar and also possible to develop the extension for power consumption, like you have said before, in test classes,
mhm.
like unit tests in C# or Java?
I think should be possible, yes, because also, so when you have tools for estimating the power consumption, then of course you can run it when you have a unit test in here, and then make a criteria saying, okay, it must be smaller than some value, and
Mhm.
and of course, yeah, I think it would be integratable, considering the availability of these tools. Yes.
So that means also for the, as I was saying, that and running it then millions of times it is worthwhile to think of reducing the energy consumption. Uh, I guess there will be more on sustainable tools in the future. Also tools in, sustainable tools. I mean tools which ensure sustainability in the terms of energy reduction.
Yeah, of
Yeah.
course. No, I think, as I said before, for developers, it's very hard to deal with the topic
Mhm.
because in the old days, when there was limited memory and limited computational resources, it was clear that we optimized the program. Okay, so we had always problems that were or programs that were optimized to fit into a computer, and today everyone thinks that computers are, infinite memories there. It is not, but we think so, and so we are not teaching, and maybe we are not not familiar with optimization, which is required here, and this should come to our mind again. Yes, definitely. There's
So
another
we would
question.
need Niklas Wirth, who I think unfortunately passed away last year,
Mhm.
because he was always, teaching that you only should use as few resources as possible. There's
Yeah.
another question in the chat.
Mhm.
Do you know if there exists tooling to automatically measure power consumption that
So
are easy usable when it goes in this direction? Yeah,
yeah,
this seems.
yeah, I'm sorry, but besides the one I mentioned, I don't know any tools. So I have not searched for that, but would be relevant, definitely. But I think it's dependent on the computer, on yeah, CPU and other aspects in here.
Also, as you said, but there is in fact, I think, a room for a lot of research
Mhm.
in this
Yeah.
area still to come. And I'm pretty sure that, as you said, there are not a lot of papers so far in this area, but I'm pretty sure this will change in the next couple of years. It has to, otherwise, you know, we are irrelevant
Yeah,
if
you're
we
right.
don't develop in this direction.
You're right. Yes, I agree.
I think we can stop here. When I look also in the chat, there are no further questions. Franz, once more, thank you very much.
Yeah.
Yeah,
Thank you.
for kind of an not out for a vision how to develop our profession.
Mhm.
Um, I hope that we will do more also in the next couple of
Mhm.
kind of semesters, terms, also in this direction. We try to develop further discourse among all our institutions. I think this was a very valuable prototype, first experience. And yeah, thank you for your presentation. Thank you to the audience, to the participants, and yeah, see you next time.
Yeah, thank you also.
Goodbye.
Goodbye.